This video is for Homework and Mastery 2.4, Section 9.2 in your textbook, using both principles of equality together. What we're going to look at here is putting together the addition principle and the multiplicative principle of equality and using them together to solve equations. In the last video we learned about adding the addition principle and adding the opposite to both sides of the equation. We also learned about the division principle, saying that you can divide both sides of an equation by the same number. Also the multiplication principle, multiply both sides by the same number and it still leave your equation equal. So here what we're going to do is we're going to put all of these together and use them to solve for our variable. We want to make sure that we are putting all of our variables on one side of the equation and then solving for that variable. So let's look at some examples. First, we're going to solve for w. I have 3w minus 9 is equal to negative 24. I already have all of my w's on one side of the equation. Therefore, what I want to do is I want to isolate the term that has the w in it. Well, the term that has the w is the 3w. So I want to move everything besides the 3w to the other side of the equal sign. Everything else is the negative 9. So I want to use the addition principle and I want to add 9, which is the opposite of negative 9, to both sides of the equation. When I do so, the negative 9 plus 9, those cancel out and become 0, leaving me with just a 3w on the left-hand side of my equation. Negative 24 plus 9, when added together, those give me negative 15. So I now have 3w is equal to negative 15. Since I have 3w equal negative 15, I think about that, and which says 3 times w equals negative 15. What is the opposite of multiplication? It is division. I'm going to divide by the number that is attached to my variable. So I'm going to divide both sides by 3. And when I do that, the 3's will then cancel out, and I get negative 15 divided by 3. So w will actually equal negative 5. Make sure that in any problem you are checking your answer by plugging in your solution to the original equation. So I'm going to plug in the negative 5 in for w of my original equation. And I'm going to have 3 times negative 5 minus 9. And I'm going to ask myself, does that equal negative 24? Well, 3 times negative 5 equals negative 15. Negative 15 minus 9 equals negative 24. Negative 24 does equal negative 24. So, w equal to negative 5 is my solution for this problem. Let's look at another example. Here I want to solve for x. I have 9x equals 6x plus 15. Notice I have x's on both sides. My variable shows up on both sides of the equal sign. I'm wanting to move my variables all to one side of the equal sign. So I want to get this x to the other side. So I want to add its opposite to the other side of the equal sign, and therefore I'm going to say that I'm going to add a negative 6 to both sides. When doing so, that gives me 9x plus a negative 6x is equal to 6x minus 6x plus 15. This 6x plus the negative 6x will eliminate each other on the right-hand side. 9x plus a negative 6x will leave me with 3x equal to 15. 3 times x equals 15. Opposite of multiplication is division. So I will divide both sides by 3, which will leave me with x equals 5. Again, remember to always check your answer in the original equation. Remember to check the 5 in place of both x values. So I put 9 times 5 equals 6 times 5 plus 15. 9 times 5 is 45. Does this equal 6 times 5 plus 15? 6 times 5 is 30 plus 15. 30 plus 15 is 45. 45 does equal 45. Therefore, my solution checks out. Let's look at another example. I have 9c plus 5 is equal to 3c minus 13. Again, I need to make sure that I get all my c's on one side of the equal sign and simplify as much as possible. But I also notice that I've got a plus 5 on the left-hand side. So I can start this off one of two ways. I'm going to go ahead and add the opposite of positive 5, which is a negative 5 to both sides. This way it will leave me only with a 9c on the left-hand side. And I combine my negative 13 plus my negative 5, leaving me with a negative 18. So now I have 9c is equal to 3c minus 18. I still have c's on both sides, so I need to move the 3c to the other side by adding a negative 3c to both sides, which I have done here. I've added a negative 3c to both sides of the equal signs. When I do, 9c plus a negative 3c will leave me with 6c. On the right hand side, the 3 c's will cancel out, leaving me with a negative 18. 6 times c equals a negative 18. So I can divide both sides by 6, and I get this, 6c divided by 6 equals negative 18 divided by 6. The 6's cancel out, leaving me with only a c. Negative 18 divided by 6 is negative 3. Again, make sure that you check your answer in the original equation. Plug the negative 3 in for both c's. I have 9 times negative 3 plus 5 is equal to 3 times negative 3 minus 13. This gives me negative 27 plus 5, which becomes negative 22. 3 times negative 3 is negative 9 minus 13. Negative 9 minus 13 is negative 22. So those do work out. Now what happens if we have a parentheses involved? Anytime an equation contains parentheses, we want to remove the parentheses first, and then solve the problem just as we have been. We remove the parentheses by using the distributive property. We distribute anything outside the parentheses into the parentheses. Let's look at an example. I have 5d minus 6 times the sum of d plus 1 is equal to 2d minus 6. I can't simplify inside the parentheses because d plus 1, that's as simplified as it gets. What I can do is I can distribute this negative 6 into the parentheses. Remember that the negative sign does go with the 6, so I take negative 6 times d and negative 6 times 1. When I do so, that gives me a negative 6d plus a negative 6. Now I can combine like terms on the left-hand side of the equal sign, 5d minus 6d, which will give me a negative d plus a negative 6 equals 2d minus 6. I need to try to get the d by itself, so I'm going to add a negative 6 to both. I'm going to add a positive 6 to both sides. And if you notice, I've added a positive 6 to both sides. These 6's will cancel each other out, as well as these 6's. Now I have a negative 2d, negative d equals 2d. I have a d on both sides. I have my variable on both sides. What I need to do is I need to move my d's all to one side. So I need to add a negative 2d to both sides. Negative d minus 2d equals 2d minus 2d. Simplify and I get negative 3d equals 0. If I divide both sides by a negative 3, I get d is equal to 0. Again, remember to always check by plugging your solution back in for all areas of your variable. So I would plug in 0 here, here, and here of my original equation. This one does check out. Please make sure that when you're looking at these types of problems that you first eliminate any parentheses that you have by using the distributive property. After that, you try to get your variables on one side, move all your numbers without variables to the other side, and then divide by the number that is attached to the variable. If you have questions or need any help, please let one of us know. We'll be glad to help you.